Okay, welcome back. And so we're going to use an example to demonstrate how we can solve trigonometric functions or evaluate a limit of a trigonometric function. And in this case, what we're going to do is we're going to use an identity to help us solve this. Okay, so notice that we have this here. We've got 1 minus cosine theta. Okay, we've got theta in the denominator. Okay, but the way it looks right now, well, there's a couple different ways we could do this, but what we're going to do is we're going to multiply the top and the bottom by the conjugate so that we can get an identity, so we can use an identity in the numerator to get sine up there instead of cosine. Okay, so let's start by multiplying the top and the bottom by the conjugate, 1 plus cosine theta. Okay, and so this is going to become the limit as theta approaches 0. Now the top is going to become what? Well, it's going to become 1 minus cosine squared theta. And then the bottom becomes theta plus theta cosine theta. Okay, in fact, let's do this because I'm not sure if I want to do that. Always leave it out and then see what you get first before you distribute. So we'll just leave it factored. Usually you want to leave things factored. Oops. Now, okay, so now let's simplify the top so we can use the Pythagorean identity. So 1 minus cosine squared theta is going to give us sine squared theta, so that's going to equal the limit as theta approaches 0 of, now it becomes sine squared theta over theta times 1 plus cosine theta. Okay, so that's where we're at. Okay, so now notice that we've got sine squared theta and theta here. Okay, and so let's split that up because what we're looking for is we want to find, we want to create expressions that we know we can find the limit of. Okay, and we can and also be able to use our limit laws and all the things in our toolbox, right? So notice we got, again, theta here. We've got sine squared theta. So why don't we split this up, because then we can match up sine theta over theta, right? So we can rewrite this like this. The limit as theta approaches 0. And we'll do sine theta over theta. Okay, so we know, we're familiar with that one. And then we can have the rest of it, which is going to give us sine theta over 1 plus cosine theta. Okay, so now what? Well, now we can use our limit laws. So again, so we have a product, so we can do our limit laws. I'm going to do, and then we can use the quotient law, right? So we can write this as what? The limit as theta approaches 0 of sine theta over theta. So we can do that one, right? Right? And then times the limit as theta approaches 0 of sine theta divided by 1 plus the limit as theta approaches 0 of cosine theta. Now here I just put 1 because, again, we should know by now that the limit of a constant is just the constant. So the limit as theta approaches 0 of 1 is just 1, okay? And then now we can take all of these limits, right? Well, what does this become? What's the limit of sine theta over theta as theta approaches 0? Well, it's 1, right? So this becomes 1 times the limit of sine theta is 0, and the limit of cosine theta as theta approaches 0 is 1, so we get 1 plus 1, which is 2, right? Well, which gives us what? Well, this is going to be 0. And so now we just showed that the limit as theta approaches 0 of 1 minus cosine theta over theta is equal to 0. By just using the results that we did in the last, that we obtained in the last couple of videos, right? So all we did was use the results that we obtained and we just demonstrated and showed in the last couple of videos, and using the limit laws and other things in our toolbox. So again, just practice. You know, the more you practice this stuff, the more you expose yourself to things like this, and make sure you review your identities if you have to. But the more you practice this stuff, the more you're going to develop a repertoire of things in your mind that when you come across something that might look a little bit different, you can use what you've practiced, use the things that you've already come across to help you solve problems that you may not have seen before but are similar. And this is the key to doing well on exams and quizzes, is by practicing problems like this and going through the solutions, trying to solve it on your own first, and then go through the solutions or get help, ask questions. And the more you go through and work through problems in mathematics and in any other field, in any other skill, you'll find that you'll get better at it, okay? So anyway, have a great day, and I'll see you next time.